Transmission and distribution system full explanation. The transmission and distribution T&D system is the backbone of the electrical power supply network. It delivers the electrical energy generated at power plants to consumers such as industries, commercial areas, and households. The entire T&D system works in stages to ensure efficient, reliable, and safe power delivery. 1. Generation gives transmission gives distribution flow of power generation. Electricity is generated at power plants: hydro, thermal, solar, wind. Typical generation voltage: 6.3 kilovolts, 11 kilovolts, 13.8 kilovolts. Transmission system carries bulk power over long distances at very high voltage VHV. After generation, voltage is stepped up using transformers to reduce losses. Distribution system delivers power from substations to consumers at medium and low voltages. Voltage is stepped down at various stages until it reaches homes. 2. Transmission system high voltage network purpose transmit large amounts of energy over long distances. Minimize line losses, IYR losses, improve system stability, and reduce voltage drop. Transmission voltage levels depending on the country. Typical levels are high voltage HV, 66 kilovolts, 130 to kilovolts. Extra high voltage EHV, 220 kilovolts, 400 kilovolts. Ultra high voltage UHV, above 400 kilovolts, for example, 765 kilovolts, 800 kilovolts. HVDC types of transmission. 1. AC transmission, most common worldwide. Uses three-phase lines, easier to transform voltage levels. 2. DC transmission, HVDC, used for very long distances under water cables interconnecting to unsynchronized grids, lower losses compared to AC. Components of transmission system: transmission lines, towers, conductors, insulators, circuit breakers, current transformers, CTs and potential transformers, PTs, substations, transformers, step up and step down. Advantages of high voltage transmission: less current gives less losses, smaller conductor size, improved system efficiency, more stable power supply. 3. Distribution system supplying homes and industries. Distribution begins from the distribution substation, typically 3311 kilovolts or 66/11ths of a kilovolt. Distribution voltage levels: primary distribution, 11 kilovolts, 6.6 kilovolts, 33 kilovolts. Secondary distribution, 400 to 130ths of a volt. 3-phase, one-phase distribution network. Types: 1. Radial system, simple, low cost, mostly used in rural areas. Disadvantage: less reliable, one fault interrupts entire line. 2. Ring main system, power is fed from two directions. High reliability, used in urban areas. 3. Interconnected system, multiple substations connected. Very reliable and stable, common in major cities. Distribution components: distribution transformers, 11 kilovolts, 400 volts poles and overhead lines, underground cables, fuses, reclosers, sectionalizers, ACB, MCCB, MCB energy meters. 4. Major differences: transmission versus distribution. Feature: transmission distribution voltage very high, medium, and low purpose long distance bulk power, power delivery to end users. Conductor size: smaller, larger losses, low, higher type of lines, mostly overhead. Both overhead and underground protection. Complex relays: CT, PT, simple MCB, MCCB. 5. WHY step up and step down voltage. Step up voltage at power plant reduces current, reduces IYR losses, increases efficiency. Step down voltage near consumers, safe for domestic use, compatible with appliances, easier to distribute. 6. Applications in real life: transmission lines connect hydro power plants to national grid. Distribution lines power homes, offices, schools, industries. Substations maintain stable voltage levels. HVDC links connect countries and long-distance grids. 7. Common equipment in T&D systems: transformers, step-up, step-down isolators, and circuit breakers, lightning arresters, bus bars, capacitor banks, power factor improvement reactors for voltage control.